In this video, we're going to look at some basic operations defined in a data frame. So if you remember from the last video, we defined a data frame that contains the population and area of 4 states. So this is how we went about it. We defined 2 series, population and area, and then use the 2 series to create the data frame. So if we were to execute this, this is what the data frame looks like. So along the columns, we have the state abbreviations as the indices, and then the columns are labeled population and area. Okay, so now let's suppose, given the information that we have, we'd like to create a new column of population density. So if we have, population and the area, if we just divide the population by the area, we get the population density. So so let's see how we could do that. So here's a statement that achieves this. So states is again our data frame. So I'm defining a new column. So here, by referring to a new column with the label density, I'm creating a new column, and this column is derived from the 2 other columns I have defined in my data frame. So it's the population, and I am multiplying this by 1,000,000 because that's how the population is defined, and divided by the area in square miles. So let's run this and see what we get. And here we are. So this created new column, density. That's just the population divided by area. And if we look at this list, unsurprisingly, New York State has the highest density among those 4 states we're considering. Okay, so now if I just want to show you syntax for referring to a column. So this is in the previous example. So if I want to refer to a column, I'm going to use the square bracket notation, and inside there I put the column label. So in this syntax, I'm just referring to the column area. So this is one way of going about it. And then alternatively, we could also, data frames allow you to use a dot notation. So these 2 are equivalent. So instead of using square brackets, I just use, data frame dot the column name. Now the dot notation can be problematic if the name of the column has a space in it, so that could be problematic. So generally speaking, I would suggest that you use a square bracket notation in general, but it's good to see that that there are one other possibility there. Okay, now the next thing we're going to look at is how to reference specific cells in the data frame or ranges of cells in the data frame, because oftentimes when we want to manipulate data in the data frame, we're not necessarily manipulating all the data, so we need to see how we could reference specific areas in the data frame. Now, to achieve this, it turns out there are 2 methods that allow us to do that, and the first is iloc. And iloc works using the absolute positions within the table. We're going to see that in a second, examples of that in a second. And index 0, 0 is being the top left corner of the data frame. And the second method is loc, and that uses the column headers and the row indices, which we've assigned to our data frame. So maybe, you know, the I in iLog stands for implicit, so it's the implicit index. So maybe that's a way to get you to remember the differences between those two. So let's look at an example of using iLog. So here's states, and I'm going to use iLog to refer and give it two indices, 0 and 0. Now, so again, iLog is implicit index, I for implicit, and so here the labels we have: California, Texas, New York, Florida, and the column labels are the explicit indices. So the implicit indices, well, they're implicit, so they start at 0. So we have to, and the first column is column 0, and then the second column is 1, and then the third column is 2. So when I say iLog 0, 0, the first index is always the row index, and then the second one is the column index. So 0 along 0 row at index 0, column at index 0. That's what we end up with this. So let's give that a try. And here we are, 39.6 as we'd expect. Now let's try another example with 2 as the row index and then 1 as the column index. So what we'd expect here is that 0, 1, 2, and then 0, 1. So we're looking at this value. So let's take a look. If that's the case, it's going to work out. Yes, this is exactly what we expect. So now we have an understanding of how iLog works. So now let's look at how we can refer to a range of cells within a data frame, and we're going to do that using the slice operator. So here we have the states, the data frame, and here's the data that we've initialized it with. And let's suppose I specify these ranges. So here I'm saying for rows, I'm going to start at index 2 and go up to 3. Now, because these indices are positionals, they're implicit indices, this acts like a list. So, which means that row 3 is not included in this. So the only row that's included is just New York in this case. So this is not part of it. And on the column side, I'm specifying that I want to go up to column 2, but I'm excluding 2. Again, because these are positional indices, I'm excluding the maximum value that I specify. So what I end up with is just this subset of the data. Okay, and then as you can see, that's the output I got here. Okay, and just another quick example. So iLog on the row side, I'm saying start at 2. So from 2 on. And colon with nothing else means everything. So on the column side, I'm including all the columns. So what I would expect for this to output is this over here. So let's take a look. So it's New York and Florida, we'd expect. And there we are, New York and Florida. Okay, now let's jump to loc, the other way to refer to cells. And and then, as I've mentioned before, loc uses the explicit column header and row index. So let's take a look at an example. So in this case, I said loc, and I'm also going to use the slice operator. So let's say along the rows, I'm going to go up to New York, but in this case, because it's in the explicit row index, New York is going to be included, and on the column side, I'm going to include everything up to and including population, the population column. So let's take a look, and that's what we have. So New York is included, and population, well, it is the first column in our data frame, so it is included. Okay, now another really powerful feature of data frames is to be able to filter data based on some criteria. And then the criteria we could specify using a Boolean expression. So let's take a look at an example. So again, here's our states data frame. So let's suppose I'm interested in, outputting the states where the population is greater than 25 million. So I'm going to use the loc method for that, but in the square brackets is where I can specify my criteria of my selection criteria. So here I'm specifying that I'm only interested in states where the population is greater than 25 million. So if this works as we think it should, then we should only get the records for California and Texas. So let's take a look. So California and Texas are the two states with a population greater than 25 million. So as we move forward with the course, you're going to see many, many more examples of doing this, and this is really a powerful feature in pandas. So we're going to be using it quite often. Okay, here's another quick example. So let's suppose we're only interested in outputting the area of the states where the population is greater than 25 million. So in the previous example, we just output all the columns, population, area, and density. But if we just want to output a column, so after we specify the criteria, we could specify our columns, in this case, area, and let's run this. And here we are. It output just the area for these two states, California and Texas. Okay, the last topic we're going to look at in this video is how to read a data set from a file, because this is the more typical scenario of how we get data into data frame. So you're typically provided with a file that you want to import into the data frame, so you could do the manipulations that you want to apply to it. Now, for this example, we're going to look at a file that's available to you at this URL. So you want to jot this down. And this is a very simple file. It's a CSV file. So CSV stands for comma separated values file. This is typically a file that you could open up with Excel. But it's a text file, so the values are separated by commas, and this is the most typical file format that we're gonna be working with in this class. So take a look. Actually, we could click on that so we could see the contents of the file. So we have all the presidents through President Obama, and in a column name, and then their height in centimeters. Okay, not a particularly very interesting or rich data set, but it's good as for a quick example. So you need to download this file, save it, and in the same folder where you have your Jupyter notebook so you could read it correctly. And now to read the file into DataFrame, there is this very powerful method called read CSV, and it takes as an argument, it's in the simplest form, we just supply the name of the CSV file that we want to read, and it takes the contents of the file and puts it in a data frame. So PD for pandas, and also as a convention, you see many people name their data frames DF for short for data frame. So what the data structure you're dealing with. Okay, so that's what we're doing here. So let's run this as executed, no output as we expect. And I'm just going to show you a few operations to help you kind of, observe some properties of the data set. So the first operation is named head, which looks at the first few entries in the CSV file. I think it's the first 5 entries in the file. So if I execute it, you can see the first 5 entries in the file, our first 5 presidents and their heights. As you're exploring data set, you typically want to get some basic statistics about a column within the data set or the entire data frame, perhaps, but let's just focus on a particular column. In our case, it's just the president heights. That's the meaningful column that we're looking at. So given a column height in centimeters, we could call the describe method to get some statistics about that column. So if we execute this, it tells us the count of values, the mean height in centimeters, the standard deviation, the minimum, and then the percentiles of height. So this is quite meaningful just as a way to kind of summarize what we're looking at in our data. Now, another very, very useful operation is to look at the distribution of the data, of a column in a data frame. So we could plot a histogram very easily. I'm going to show you an example. So first off, we need to, so plotting in pandas is achieved using a module called matplotlib. So that's something we're going to be using quite a bit later on. And here, this first line tells Jupyter that we'd like the histogram to appear within our notebook. So it's inline in the notebook. So this is a command to do it. And then to plot the histogram, we're just using the hist method. So it's df, so referring to the column of which we want to generate the data frame. So let's run this and see what it looks like. And there we are. So we see the distribution of heights of the president. So this is a bit more descriptive than just looking at a single statistic like the mean, min, and max, because it gives you an idea of the entire distribution. And the histogram function is something that we could customize quite a bit. So we'll look at that at some point later in the future. So this concludes this video. So hopefully this gives you a good sense of how to apply some basic operations on a data frame to start to understand what data that you're looking at. So thank you.